All right, I'm just going to read this as I see it. This is the 6.2 lesson, solving by factoring. We're doing quadratics. And just as a brief overview, I know it's been a week since we talked about this. Quadratics have a U-shaped graph. It's easy to remember what kind of form the graph takes because the word quadratics has a U in it. So we've got a U shape that can go up or a U shape that can go down. We've been graphing. Now we're going to be solving by factoring. And factoring is more or less just a matter of taking two binomials and or taking a trinomial and breaking it down into two binomials like that. So going backwards. So we're going to factor this into this. Another version of factoring would be something like take the number 24. The number 24 could be a whole bunch of different things. It could be 4 times 6, which is factors of 24, or it could be 2 times 12, or it could be 3 times 8. But we're going to look for the exact solutions to the quadratic functions as we go. And when we say solutions, we mean like mathematicians. When the mathematicians say solutions to quadratic equations, we're really talking about the x-intercept. There's two x-intercepts on most quadratics. Some quadratics only have one. Some quadratic equations have no x-intercepts at all. So in that case, you would call it no solution. All right. In this case, we have two solutions, two x-intercepts. Another word that you'll hear mathematicians say is roots. We talked about that last week. Okay. All right. And we'll try and get this to be as visible as possible. We'll see how things go today. All right, I'm doing a 6.2. I'm on that print off where that I sent to my team earlier last week on Microsoft Teams. I'm on page 249, and it goes all the way to 253. I don't know if I'm going to have time to get to 253 today, but I always print off more than I need just to make sure I have enough to cover with you guys. All right. So in the last lesson, we discussed solving quadratic equations by taking the square root of both sides of an equation. This method works well when one side of the equation can be expressed as a perfect square, which is this right here. So you square root both sides, and don't forget, when you square root both sides, always put the plus or minus symbol there, okay? Now, in this case, it didn't quite work out as easily as it could have, I guess. I mean, if you work this out, it'll be x minus 1 equals plus or minus the square root of 8. And then you have, anyway, so this one, these two are not, this is not a solution to that. This is just another format. They're saying that x squared is, blah, blah, blah. You square root both sides, okay? And then you solve for that. Obviously, this would turn out to be a imaginary root, right? And so when they say no solution, well, there's an imaginary solution. And I know that doesn't make sense, but we'll get into more detail later, okay? So you will often encounter quadratic equations where we do not have perfect squares. Suppose you were asked to solve this. So how do we proceed? All right. In this section, we will cover a few examples of using factoring to solve quadratic equations. There are 4 factoring techniques that we need to make sure we can perform: greatest common factor, grouping, factoring trinomials, and then factoring trinomials of this form where a is not 1. A is not equal to 1. Right? And this one's a is equal to 1. These are usually easier to solve, all right? Usually easier to deal with, okay? And we'll get into more detail as we go. And we'll just take it slow. If this section takes us 2 days, then so be it. It doesn't matter, okay? So factoring the greatest common factor. This is the factoring technique that can often simplify an equation quickly. Find the greatest common factor common across all terms of the equation to write the equation in factored form. Well, this one is pretty simple. You see a factor of 3 here being common. So the GCF would be 3. Okay, so that means I can pull a 3 out from both terms. And if I do that, this x is left alone. And over here, we have 100 on the inside. So this is called factored form. Okay, so we factored it out into this times that. Now, let's move on. Let's keep going and keep practicing this. All right, I'm going to try and clear that up the best I can. All right. All right, now we have a GCF here. It looks pretty obvious, right? We have, not only do we have a 7, but we have a minus in front of both terms, okay? And usually if there's a minus involved, I'll go ahead and pull the minus out. I'll go ahead and say the common factor is a minus that number. So in this case right here, I would probably say minus or -2, okay? But in some cases, it's not necessary. In some cases, it is. We'll use our discretion as we go. But also, I want you to notice, watch out, because there's a V here and 2 V's here. What's common? There's 1 V in common, okay? And so when you pull that -7V out, let's see what happens. So I pull out a -7V. What's left here is a 1, okay? Then I pull out here a -7V. So that means we have a, if we pull that negative out, then we're left with a positive. If we pull out 7, that's going to be 11, because 11 times 7 is 77. And then if we pull out a V, then there's going to be a V there, okay? So now this is factored form. All right, let's go down here and practice this one. This one is, this could be a little bit, we'll see how things go here, but obviously you can see that 2x is common. Let's see if pulling that minus out in front would actually help us here. In this case, it may not. So I'm going to pull out a 2x, and I'm going to pull 2x out from here. So it leaves me with a 2x. And then I'm going to pull out a 2x here, but there's a minus in the middle. So if I pull out the 2x, in this case, it wasn't appropriate for me to pull out a minus here, because that would have been too much information, okay? All right, so let's go down to the next one, and let's see what we got here. So what do you think the GCF of 14 and 21 would be? That would be 7, and then we have a y on both terms, so we can pull out a y. So my GCF is 7y. I pull that out, and I'm left with 2y for the first term, minus 3 for the second term. That y goes away because I pulled it out, okay? It's minus 3y because I pull out a 7y. These are all factored forms of these binomials here. These are called binomials because they're two-term expressions, all right? So check, we got greatest common factor down. Now, grouping is a different thing. We'll talk about that in just a minute, all right? Now, let's go over here and chat about the grouping part here. Grouping is not as hard as it looks. It's just usually when you have a format like this where you have not 2 terms, not 3 terms, but 4 terms, most of the time what you're going to want to do is, and most of the time in these books, these problems that these authors of these books set up is pretty simplistic math problems where all you have to do is just put parentheses around the first two in the set, the first set and the second set of terms, and then you pull out a factor that's common. So basically you treat this just like we did a minute ago and pull out what's common. Same thing over here. You'll treat this and pull out what's common. So it's kind of 2 problems in one, all right? So in this case, the GCF of the first part would be z, all right? You see the z in both terms? So we've got x here if I pull out a z, and I've got y here if I pull out a z, all right? Now let's come over here. Plus, what's common between these two terms? All right, we're grouping. That's what's happening here. We're factoring by grouping. So we group this, and we're going to pull out what's common, and we have 5 for that common factor. And what's inside? We have an x and a plus and a y for that. And so x plus y is what's common here. But look at this. Look at this as a whole. All right, do you see now what's common across the whole thing? You see that x plus y is common across both terms. So what we can do is pull that out just like we would be factoring, all right? So I'm going to pull out the greatest common factor, which is this plus this. And then I'm going to put parentheses and say, okay, what's left over here? Z. Okay, what's left over here? Plus 5. Now you can see that we've got 2 binomials set up. And if you multiply these out, it would turn out to be this, okay? It's not a nice, neat little trinomial because you've got 3 different variables going on here. There's no squares or anything, okay? All right, so let's go to the next one. Same situation, all right? We block off both sets here, and we look for common factors, okay? So in this case right here, what's common between these two terms is an x squared, okay? And so if I pull out an x squared on the first term, I have 5x, all right? If I pull out an x squared on the second term, I have a plus 4, all right? Then, now we're going to look at these two sections here. So what's common between these two things, 10 and 8? The greatest common factor would be 2. Okay, so I'm going to pull out a 2, and 2 times 5 is 10, and there's an x there. I bet you can see what's fixing to happen already, right? If I pull out a 2 here, that leaves me with 4 because 2 times 4 is 8, right? So now look at the common factor. They have 5x plus 4 on both terms. So think of this like 2 terms here, okay? Pull out that common factor over here to the left, just like we did earlier in the sheet, and then I want you to multiply that because this is kind of distributive property, right? So we're going to say x squared plus 2 for that other term. So you see the x squared and the plus 2. All right. So that's called factoring by grouping. So look at how this looks. This is a not a, I don't know how you'd say it. I wish I knew this, but it's probably a quadnomial or something like that. You got 2 binomials added together make a quadnomial, I guess. I don't know. I'm just making stuff up as I go, okay? All right, so now let's go. We've got another situation here where we can pull out common terms. Now you got to be careful sometimes because it might be that you could reorder some of this to match out to be to have some common factors. If you're not getting common factors this way, you could just swap a few terms and then see what happens there, okay? All right, but in this case, like I said, the authors of this sheet or this worksheet here made it to where it should be easy enough to just pull out. We're trying to teach a new topic, so we're not going to make it as difficult as it can be right now. Okay, so if you'll notice in this situation, I'm pulling out an x squared. So x squared here and x squared here, there is 2 x's inside of there. So I pulled those 2 x's out and I'm left with 1 x right there, okay? So if I pull an x squared out, I get 4x plus, I pull out an x squared here, that's a 1, okay? So when you multiply x squared times 1, you get x squared. Now let's go over to the next part. Put a plus, pull out what's common here. You should be able to tell pretty quick that 5 is common here. So 5 times 4 plus 1 and done. Okay, now look, you've got it again. So we've got that same common factor here, and we're going to pull that out and put that over here. So we're going to put 4x plus 1 and then multiply it by x squared plus 5. Do you see why? Because you've got an x squared here and a 5 here, and we've pulled out the 4x minus 1s, and that's what's left. All right? So I'm going to pull back for just a minute and give you a chance to catch up if you're a little behind. So I'll just let that sit for a second. All right, the next thing that we're going to be talking about is factoring trinomials. All right, so we did step 1 was GCF. All right, step 2 we did grouping, and then step 3 we're going to be factoring trinomials. All right, I'll just put factoring trinomials like that. Okay, of the form 1x plus bx plus c. So these are going to be very simple to do. And so we'll get to the part where it's a little bit more difficult here in a minute. But this is pretty straightforward. There's not much to it, okay? So we've got factoring trinomials of the form x squared plus bx plus c. So for trinomials, and remember, this is a quadratic when you make it an equation. So if I set it equal to something like here, it's equal to 0, then that tells me I've got a U-shaped graph with two roots or two solutions. Now it could go, in this case, we are definitely going to be up, facing up, because our A value is positive. You see that? So that A value in front of that x squared term is positive. That means these are always going to be facing like this. Okay. Now it could be possible that you have an up-facing quadratic and it never touches the x-axis, right? All right. So you would have no solutions at that point. But we're going to go into more detail than that. Okay. So for trinomials where the coefficient of the x squared term is 1, we can factor using the following steps. Find two numbers that multiply to give C and combine through addition, subtraction to give the value of B. If P and Q are those numbers, then the factorization is x plus P and x plus Q. Now remember this from last week. You remember we also talked about H and K being the vertex, right? Well, P and Q are the roots or the solutions. All right. So those are different. You can't think of this as H and K. That's why they give them different letters, because we're talking about two different things. Here's the vertex and here's the solutions. You see the difference there? Sometimes you'll have a situation where the vertex itself is the solution. Like if, let's say for instance, you have 0, 0 as your vertex. Well, that would also be P and Q in that case. And that's the only case, well, that's one of a few times that you will actually see that happen, okay? So now let's come down here and look at this. So we've got, we're going to solve these by factoring. So we're going to have, we know for a fact in this case, we're going to have something that looks like x plus something and x plus something, okay? So basically what's happening here is we're going to take this number and we're going to, if you'll notice that it's negative, right? But this right here is important that you remember this, because if this number is negative, that means the values are going to have a different like one will be positive and one will be negative. Okay, the signs are going to be different when we're talking about P and Q. So in other words, it'd be like if you go back up here, we're going to have a situation where like the P here is negative and the Q here is positive. That's kind of the situation we're having here. You could have a situation where the solutions are both positive. Well, we'll get to that in a minute, okay? But right now, we know for a fact that 42 is what we need to look for as far as multiples. And if you'll come over here to the left, 42 is the number we're shooting for. So we're going to go through the list of factors of 42. And what we're going to do is we're going to look for a difference between these factors of 1, okay? So watch out for this. So here we go. So we're going to go 2 times 21. If you'll notice, we're not there yet. We're looking for factors that are like 1 apart from each other. And you could probably already figure it out. If you go on down, dot, 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 you'll know that 6 times 7 is 42, right? Well, if you notice, 6 and 7 are 1 apart from one another. Well, this sign is negative, so that means that you would have to have more negatives than positives. So which one of these numbers is more than the other? It's going to be 7. So I'm going to circle that, and I'm going to put -7 here, okay? And remember, we're supposed to have a P that's and a Q that have opposite signs. So we have a -7 and a +6. Now, if you'll multiply this back out, if you do the FOIL method on this, you'll notice that the inner term makes -7x and the outer term makes 6x. If you put those together, you get 1x, negative, right? And then if you multiply the last terms, you get -7 times 6, which is -42. So now we've found our P and our Q, okay? So our solution is, now this is important that you understand this, P is -7 and Q is 6, okay? Now, okay, so let's go back and look at this, all right? I'm going to pull this back and work on the next problem. Okay. All right, we're going to do the same thing, but with a little bit more advanced problem here. So we've got, this time, I don't like necessarily how we jumped from where we were at to where we're going here, but I do want you to understand something. Just because there's a 2 here does not mean that this is actually not going to work in the same fashion as what we did. If you'll notice, we have a GCF for all 3 terms, okay? And so what we have is a GCF of 2, because 2 goes into 2, 2 goes into 6, and 2 goes into 56. And every time you need to pull off, step 1, you need to pull off that GCF. It doesn't matter what kind of problem you're working on. Like here, we don't have a GCF, right? Well, we do, it's a 1, but you would pull it off if it were anything other than 1. So in this case, we're going to pull off a 2, and we're going to rewrite the equation here. All right, and so we get x squared plus 6x minus 56, okay? Now, okay, so let's go over here and focus in. I'm going to cover these 2 parts up. And what we're going to do is we focus in on this one part here. If you'll notice, I've got a 1 now for my A term, okay? And so I can set it up like I did a minute ago, where it's two binomials like this, with an x in front, a plus here. Now, I want you to understand this. Let's go through this really quick. The 2 things that are important here are 56 and this symbol right here, okay? This 56 is what I'm trying to shoot for as far as we're going to factor this out into something times something, but those 2 things are going to be 6 units apart, and this symbol right here means that the 2 terms here are going to have the same sign. So we're going to write the word same sign, all right? So that if this is a minus right here, you're going to have different signs. If this is a plus here, you're going to have the same sign. So in this case right here, since this is -56, we know for a fact that we have to have 2 negative numbers here. We're going to have 2 negatives. So what would that graph look like real quick? Well, it would look something like this, where we have 2 negatives here, okay? 2 negative roots. All right, so now, well, we'll get into that later in just a second, but I want you to, I'm actually confusing you, but we'll get into what this means later. I'm going to scoot on down and let you look at this real quick, okay? So what the step one is we factored out the 2. Step 2 is we're going to solve for the 56 here. So we're going to take 56 and we're going to go through it. Obviously, 1 times 56 is not right because I need to be 6 apart from one another. If you go down the list, let's see, we got 2 times 20, 25 plus 3 is 28. 2 times 28, so in other words, let's go really quickly and look through the factors of 56. So let's see, second mode clear. Yeah, try to get this right. Okay, and what I usually try to do is go through when I have this situation, you divide by primes every time. So in other words, now 1 is not prime, obviously. We have discussed that before, but 2 is prime. So you'll see we have 2 and 28. And then what's the next prime? 3. Well, 3 didn't work out, did it? All right, so let's do 5. 5 and 11 didn't work out. So let's do 56 divided by 7. Now we have 7 and 8, okay? Well, in this case here, I made a mistake a minute ago. So let me go back and explain something. I wonder if you can find my mistake. I bet most of y'all already saw it. So if you'll notice right here, I pulled out a 2, but I didn't pull out the 2 here, and I didn't pull the 2 here. So I made 2 mistakes, actually. So I don't know what I was thinking here. So this should have been a 3 because 2 times 3 is 6. My bad. I'm sorry, guys. And then, so 2 times 28 is 56. So you'll catch yourself sometimes if you go back and look at the problem from each. So in other words, we're looking for the factors of 28, okay, that are 3 away from each other. So you go 1 times 28, 2 times 14, and then obviously 3 won't go into 28, well, 4 go into 28. Well, if you look here, 28 divided by 4 is 7, and okay, so 4 and 7 are the 2 factors that you're going to be focusing in on here because they are 3 apart from one another. All right, so I'm going to circle that. I'm going to put 4 here and I'm going to put 7 here. But if you just put 4 and 7 here, you're not going to come out with a negative 28 when you multiply these together. You remember they're supposed to have the same sign, and they do, but they're supposed to have the same sign, which is negative, okay? So that didn't work out. Something is not right here. Okay, so hang on just a minute. I'm going to pause the recording for just a second. Okay, so we've got 2x squared plus 6x minus 56 equals 0. So we've got 2 times x squared plus 3x minus 28. So everything works out okay there. All right. All right, so everything works out okay there. And we've got the signs in the right places there. We still have that 2 out in front, which is the greatest common factor. And so in this case, we have this and this. Well, there's actually a couple of things that I could do to go check myself on this, but we're not quite to that section yet. So I'm going to hold off on it. And it has to do with the quadratic formula. I could go through and check my roots by using the quadratic formula, but I'm just going to go through real quick and see what's happening here, okay? So we've got, okay, so the only factors that make 28 that are 3 apart are 4 and 7, okay? And in order for me to have a positive 3 here and a negative 28 here, oh, okay. Okay, so I made a mistake here. This is my mistake. So I've got, instead of where it says same sign, I'm supposed to have a positive 3. That means that my 7 is going to be positive and my 4 is going to be negative. So something about what I just, the explanation I gave here, that was an error also. So I've made 3 mistakes on this one problem. Oh my goodness. Okay, so obviously, if you multiply 7 times -4, you get a negative here. And if you multiply, if you add 7 and -4 together, you get +3. So that works out. I'm just getting my numbers confused or something this morning. I don't know what's happening. All right, so we have our P here and our Q here. You see that? Because X plus P and X plus Q work out like that. Now we're going to actually solve this problem, all right? And let's see what's happening here. So I'm going to come down and work this out. So if you'll notice, it's called the zero product property. So I'm going to write the word zero product property. When you take any number and multiply it by 0, I can get 0. And another way is the commutative version of this would be 0 times any number is also 0. So if I were to put 0 in either one of these places, I would come out with 0. So there's 2 different kinds of solutions that I can have, all right? Now the 2 doesn't really matter here. You could just cancel out the 2 and just forget it, because what's fixing to happen is I could replace this X term with 0, all right? Or I'm sorry, you could set, where that 2 went from? Okay, so in this case, if I divided by 2 here, if I divide 0 by 2, does that change it? That stays 0, right? And this 2 divided by 2 is 1. So you really can get rid of that and rewrite this like this. So we can say this times this equals 0. So literally that 2 just kind of washes away, okay? Okay, in this case right here, we're going to say if this guy is 0, so we're going to set x plus -4 equal to 0. And then we're going to also set x plus 7 equal to 0. And we're going to get our 2 solutions, all right? So our 2 solutions, the way you would write them out is you write them in brackets like this, and you'll separate them by a comma. So let's solve this right here. So we would have 4, take away 4 is 0, right? So my first x would be 4. And in this case right here, 7 take away 7 is 0, right? So x would be -7. So there's my roots, there's my solutions. Now it looks nothing like this, and that goes back to that graph. You remember how I showed you on the graph here on the calculator that it turned out that one solution was negative and one solution was positive, because there's 0 right there. So that was the answer, and now you can see it. One's farther left than the other one. So we got -7 is way over here, and -4 is right there, okay? I mean, +4 is right there. So that kind of proves it. And I could have gone through and looked for the roots in the table. So if you go through the table and you look through the list, you can see that right here. 4 has they call it zeros or roots or solutions. So there's 3 different things they can call it. So if y is equal to 0, that is a root or a solution. So 4 is an answer. And if you notice, it keeps getting bigger and bigger and bigger here. Well, let's go backwards. Go back to the -7. -7 is also a 0 here too. See that? All right. So that's how you tell where the root is. All right. Let's go on that. Now I know this is a bunch of mess right here. Okay. That's because I made 3 mistakes and I had to make up for my mistakes. All right. So let's look over here and see what we can do here. Now, if you'll notice, there's not a 3 terms here. We're going to end today with this little problem. I think the problem is going to cut me off. So we're going to go, the video is going to probably cut me off. All right. So we're looking for x plus p and x plus q. So we need to go through the factors of 24 that are 5 apart from one another, okay? So the only ones that I know are 5 apart from one another would be 3 and 8. So I can put 3 here and I can put 8 here, right? But are my signs going to be the same or opposite? Well, let's look at this just a second. In order for this to be a negative 24, that means one of these has to be negative, okay? So if one of these has to be negative and I need to come out with a positive 5, that means the largest number needs to be positive. So in this case, 8 is going to stay positive, and I'm going to put a minus in front of that 3. So if you multiply that, that becomes negative 24. And if you add these two terms, you get 5, okay? Positive 5. So now we need to solve, we need to set x plus negative 3 equal to 0. And then we're going to set x plus 8 equal to 0. So that's called the zero product property. And now our solution would be x equals 3 and x equals negative 8. And the way I would write that would be negative 8 comma 3. And I can prove that to you by putting it in the graph. These are my solutions. So if you were to freehand that, you would have an 8 way over here. You'd have 8 negative, and then you'd have 3 positive. So you'd have a graph that looks kind of like that, okay? All right, so we're going to end it up today right there. And we're going to start tomorrow with when we're factoring trinomials with an a value that is larger than 1. So we're going to get to that tomorrow, okay? I'm going to leave us back for a minute. Does anybody have any questions? If you do, just stick it in the chat real quick before we close off. I know I was confusing right here. One other thing that I know I was confusing on was right here. I did not talk about the actual solutions to this part here. If you were to find the actual solutions, the actual roots or the zeros, you would set this equal to 0 and set this equal to 0, and then you'd solve for the x, and x would be 7 here and x would be negative 6 here. And so you would rewrite this, the solutions would be like here, okay? So in other words, one is negative and one is positive. All right. Yeah, and I apologize for about confusing you with that sign in the middle, but we'll get to that. It's been a while since I've taught this, and I can't remember all my rules that I go through. So, but I do remember how to solve it, obviously, but how to explaining it correctly, and it didn't work out that way. So if you have any questions before we leave, let me know, and I'll get back with you. Okay. Just stick it in the chat. And now tomorrow we're gonna go into factoring trinomials. We're gonna need page 6.2, 251, 252. I might go over a few of these 253s, but I'm probably gonna move on to the next section after a couple of these problems here. Okay, just we'll hit those as a review. Now remember, at the end of this, we will do a big review at the end on this section 6. And so number 1, GCF, number 2, grouping, number 3, factoring trinomials. That's what we've done today, okay? So we pull out common terms, or we group these 4 term expressions here in a specific way to where we can pull out what's common and pull out again what's common. And then we have 2 binomials multiplied together. So that's what those are. 2 term, binomial, multiplied together. All right. Have a good day. We'll see y'all tomorrow.